Okay, this time I'm going to cover section 3.4's homework assignment. There are only 15 of them. Well, actually, I tried to make a video once, but my computer crashed, so I had to retry it again. So actually the answer is already written here, but I'm going over each one again. Okay, so here's the problem number 1. Okay, a body moves on a coordinate line such that it has a position. So position is given in the function. It said f, but I'm going to use s. So position function is st is equal to t squared minus 9t plus 8, where the interval is 0 through 6. Okay, now part A. Find the body's displacement and average velocity for the given time interval. So what is a displacement? Well, displacement is a change, the amount changed in the position. So the particle body is moving along the number line. And for example, at time 0, when time is 0, it is at 0.8. Okay, and at time 6, it's, well, somewhere, right? So it's moving from here to here, and the displacement is the difference between those 2 points. So the displacement is equal to the final position minus initial position. So the final position, you just find S of 6, which is 36 minus 54 plus 8, which is negative 10. And the initial position is 8. So you just need to do the subtraction. So 8 disappears, 8 disappears. You don't need to find negative 10. 8 disappears, and you just need to find the value, negative 18. Okay. The unit for the displacement is length, and according to the problem, it said in meters. So the answer is negative 18 meters, which means from the initial position, it moves 18 meters to the negative direction. Now I need to find the average velocity. So average velocity, I need to find, well, the average velocity is actually this displacement with the 2 point over the time change. So change in position over change in time. That's going to be average speed. Now, change in position is I just found it, which is negative 18. Change in time. Change in time is actually 6 seconds in this case. So it's going to be negative 18 over 6, which is negative 3. The unit used is numerator is in meter, and the denominator is time, which is time. So it's going to be second, meter per second. 速度、まあ、平均速度だから、まあ、道のり割る時間っていうね。道のり割る時間。Okay, so actually this is showing the position. So it's a position. Well, the graph is not correct, but we'll assume it's like this. So let's say we have a position here at time 0 and position here at time 6, and the average velocity is just a slope between those 2 points. So that's this. Okay, this is. Okay, part B. Now I need to find the speed and acceleration at the end point of the interval. So I need to find the speed and acceleration at time 0 and at time 6. To find the speed, I need to find the velocity. To find the velocity, well, I'm going to write this one again. To find the velocity, I just need to differentiate the position function with respect to time. So you want to differentiate and you want to differentiate. You want to get the function for the velocity. To find the acceleration, you want to differentiate the velocity. So you want to get 2. Okay. So the speed is actually the absolute value of the velocity. So I just need to find the velocity first. So v of 0 is you just plug in 0 to the velocity function, which is -9, but the speed is absolute value of that. So it's going to be 9 at t is equal to 0. And at 6, it's going to be 12 minus 9, absolute value, so which is 3. And acceleration going to be 2, no matter what the t is. So a of 0 is 2, and a of 6 is 2. So in this case, acceleration is constant. Okay, so that's this part. Okay, finally, part C. So when, if ever, during the interval, does the body change direction? So body change direction means the particle, for example, moving to the left, and then decided to change to move to the right. Is this happen, or does it happen, or go right, then change to go left? So these are the point when the body changes the direction. And when it's changed the direction, what it's really happening is the velocity changed from negative velocity to positive velocity, or positive velocity changing to negative direction. In either case, at this moment, the velocity becomes 0. So all I need to do is set the velocity function equal to 0, which is 2t minus 9, and the t is equal to 9 over 2. So velocity, the graph of the velocity is like this. So velocity graph looks like this. So at 9 over 2, it becomes 0. So velocity is negative before t is less 9 over 2, which means original graph is moving to the left. And after 9 over 2, you have a positive velocity, so it's moving to this way. So this intercept indicate the change of the direction. Okay, so that's question number 1. Okay, problem number 2. The statement is actually identical to the problem number 1, but the given function is a bit more complicated. But the idea is about the same. So I'm not going to explain much, but I'm just focused on the computations. So we have a position function, st, which is 25 over t squared minus 5 over t on the interval of 1 through 5. Now, because this problem is asking for the speed, velocity, acceleration, those stuff, so I'm going to just differentiate to get all 3 functions first. So this is going to be negative 50 over t cubed plus 5 over t squared. Acceleration, you want to differentiate again. So now be 150 t fourth minus 10 t cubed. Now, let's answer the question. Part A, find the displacement. Okay, so I just need to find the displacement. S of 5 minus S of 1. S of 5 is 1 minus 1, which is 0. S of 1 is going to be 25 minus 5. So it's going to be negative 20. Okay. Average velocity going to be change in the position over change in time. So it's going to be negative 20 over 4, which is negative 5. Part B, find the speed. So I just need to find the speed at endpoint. So at 1, then just take absolute value. So which is negative 50 plus 5 absolute value. So it's going to be 45. At another endpoint at 5, it's going to be negative 50 over 125 plus 5 over 25, which is negative 2 over 5 plus 1 over 5. So it's going to be 1 over 5. For the acceleration, I need to find a of 1, which is, wow, 150 minus 10. So it's going to be 140. And a of 2, a of 5. 6 over 25 minus 2 over 25. It's going to be 4 over 25. Okay. Part C. When does it change its direction? Well, the position changes its direction when the velocity becomes 0, when the velocity changes its sign. So I'm going to set v of t is equal to 0. So negative 50 over t cubed plus 5 over t squared is equal to 0. We don't like the fraction, so let's multiply both sides of the equation by t cubed. So it's going to be this. So t will become 10. So at t is 10, it's going to change its direction. So let's see. So the first one is negative 20. Next one is negative 5. Okay, so the speed at the left hand is 45. Next one is 1 over 5. And next one is 140 and 4 over 25. And at last, the body changed its direction at time is equal to 10. Oops. Did I make a mistake? Let's see. So question is, when does the body, during the interval, does the body change direction? Select the correct choice below and fill in the answer box within your choice. Oh yeah, of course, no. I was wrong. So 10 is not correct because, yeah, I was forgetting about this. Yes, the time interval is between 1 and 5 only. So at time is 10, it is not included in the domain, not included in the interval. So we want to neglect this answer. So in the interval t is equal to 1 through 5, the velocity will never become 0. So it doesn't change the direction. So the choice is going to be B. Okay. Now move on to the question number 3. Now, equation for free fall at the surface of some planet is S is equal to 9.34 t squared. So again, so you got the position function is given like this. So how long does it take a rock to fall from rest to reach a velocity of 26.4? So I just need to find the velocity function. Velocity is 18.68 t, and you wanna set that equal to 26.4. Okay, so I just need to find this equation and solve this. You're gonna get 26.4 over 18.68. Now let's see. So the answer is like what, 26.4 over 18.68. Again, 26.4 over 18.68. So it's going to be about approximately 1.4 to the nearest tenth. Okay. So let's move on to the next question. Okay, this is a very long one, but well, problem is simple. Okay, so rocks thrown vertically upward from the surface of the moon at a velocity of 32 meters per second. And the height position is given by 32t minus 0.8t squared. Okay, So just find the velocity, which is 32 minus 1.60. And the acceleration is, maybe I don't need it, but the acceleration is going to be negative 1.6 in the moon. Yeah, the moon have like approximately 1/6 of the gravity of the Earth. So it kind of makes sense because in the Earth is like 9.8 and negative 9.8, and this is like about 1/6 of that. Yeah. Anyway, let's answer to the question. So part A is this, just asking for the expression. So that's part A. Okay, part B. How long does it take the rock to reach its highest point? Okay, so rock is move in the vertically upward for the moment, and then it started moving down. So when does it become? When does it reach the maximum height? So that's actually the time when the velocity change from positive velocity into negative velocity. So the velocity function is actually linear function. Y-intercept is 32 with a slope of negative, so it's going to be like this. So velocity is positive for a while, and after some point, the velocity becomes negative. So this corresponding to moving upward for the S, and this corresponding to moving down in the position. So I just need to find the intercept of the velocity function. So part B is velocity set to 0 and the t is equal to 20. Okay. See, how high does the rock go? So it's talking about what is the maximum height the rock can get. So we just need to plug in 20 to the position function. So the position is maximized when the velocity becomes 0. So S of 20 is 640 minus 400 times 0.320, which is 320. Okay. Now, next question. How long does it take the rock to reach half its maximum height? So it's basically talking about the height. So question is, for what value of t, the height become half of its maximum height? So it is 160. So you're gonna solve for this equation. You can divide everything by 8. Maybe multiply by negative 10. And maybe completing square or solving by using a quadratic equation. I'm gonna use completing square method. So it's gonna be like this. So t is 20 plus minus square root of 200. Okay. And you just need to change it to actually 2 decimal places, 2 decimal places, which is something I messed up. Yeah, 2 decimal places, and you're gonna get 2 answers. Okay. Okay, how long is a rock aloft? So it's talking about like, so rock is started moving upward and going down until it reaches the ground. So how long does it take? So I just need to find the time such that it is in the air. So the height is greater than 0 for what value of t. So I'm gonna solve quadratic inequality, which is this. Let's multiply it by negative 10. Become like this. And you can factor this like this. So this is a quadratic inequality with concave upward, with the t is actually 0 and 40. So this is actually less than 0 when t is between 0 and 40. So the original expression is correct when t is between 0 and 40. Okay. In fact, the original graph looks like this. It reaches a maximum height at the vertex, which is at time 20. And considering the symmetry of the parabola, you can kind of guess it should be 40 here. So the answer is 40 seconds. Okay. Now this is kind of review question, as you see that this is problem from chapter 2. So I'm not going to explain much here. It's just asking for finding a tangent line using the two points on the curve. So I'm going to show you what the question was. So you have some function given, x squared minus 2x minus 4. So that's a function. And you have a point P. That's a point P. Maybe I should change to point P. Okay. And I need to find the slope of the tangent line at point P here. So what does it do? Well, if you remember how to find the derivative, so derivative is 2x minus 2, and I need to find the derivative at x is equal to 2, so which is 2, okay? You see, so this is the slope of the curve, okay? Now, to find the equation of the tangent line at this point, I have sufficient information. The slope is 2, and it goes to 0.2 and minus 4. So the expression is going to be y plus 4 minus slope x minus x value. So that's going to give you the tangent line. Okay, so that's how you do it. So for part A, actually, this is telling you find the limit of the secant slope. So actually, you have to use a limit procedure to find the derivative, but you know, in the Pearson, you just need to find a number here. So you could do the shortcut. But if you want to do it seriously to prepare for the test, then you might have to use the following. So you have a function like this. You want to pick a point P, and you want to pick another point Q, which is different from point P. And what you have to do is find the slope of the secant line. Secant line is the line connecting 2 points on the curve. So the slope gonna be f of 2 plus h minus 4 over 2 plus h minus 2. Okay, so that's the difference in y value over difference in x value. And after that, you have to take a limit as h approaches 0. Limit h approaches 0. And that's gonna become the f dash at x is equal to 2. Okay, so you have to do some computations here. Okay, next question. Okay, so again, so you have an explorer on a small airless planet. Use the spring gun to launch a ball bearing vertically upward from surface at a launch velocity of 7 meters per second. So because of the acceleration of gravity at the planet is actually unknown number, gs, the expected ball bearing to reach a height of s. So you got the position function again, 7t minus 1/2 gs t squared. Okay, question. The ball reaches its maximum height 10 seconds after being launched. So we have some information about the maximum height, and we want to find what this is. Remember, the maximum height is obtained when the velocity slope become 0. So you want to differentiate the position function to get the velocity function, which is this. And the velocity become 10. Velocity becomes 0 when t is equal to 10. So 7 minus 10 times gs is equal to 0, which means gs is equal to 7 over 10. Okay, so that's the answer. Okay, next question is, it's kind of like a historical stuff, but yeah, it's kind of long sentences, but all it's important is here. So for any given angle, the ball's velocity is given by this expression. So the velocity function is given in this question, which is 9.8 times sine theta times t. Okay. And we need to find the velocity of the ball during the free fall. Now let's look at the image here. Okay. So in the free fall position, you know that theta is actually 90 degrees. So on the free fall situation, theta is 90 degrees. So in that case, this part become 9.8 sine of 90 t. But the sine of 90 is equal to 1, so it's going to be 9.8 t. So the choice A is the best one for this case. Okay. For part B, so building on your work in part A, what constant acceleration does a freely fall body experience near the surface of Earth? So it's basically talking about the acceleration near the surface of Earth, which is the value k here, okay, and that's actually 9.8. And the unit is meter per second. Okay, next one. Now you got graph of the velocity. So velocity function is written in here, and we are asked to find the problem. So when does the body reverse direction? So this is same thing as the problem number 1. So when the position change, it's moving from to the right to the left. Okay, so that happens when the velocity is 0. Actually, more precisely, the velocity, if velocity is positive, the position is moving to the right. When the position velocity is negative, it's moving to the left. So when the velocity change its sign from positive to negative or negative to positive, that's the time the moving object changes its direction. So in this graph, it's moving to the right because the velocity is positive. So velocity is positive, 0, negative, 0, positive. So at x equal to, at time it is 2, it's stopped moving to the right. And after time it is t is equal to 2, it's moving to the left. Okay. And at time is equal to 4, it stopped moving and it's moving to the right again. So the first 2 seconds, it's moving to the right. It's actually moving faster than getting slower, kind of. Yeah. So for the first 1 second, start move slowly, making first, then getting slow and stopped. Then it start to move to the left, like this, getting faster. At time 3, getting slower. At time 4, and it stopped at time 4. Then it start to move again in this way. Okay. So the first question, when does the body reverse its direction? Well, at time is equal to t and time is equal to 4, when the velocity is 0. When is it moving at a constant speed? A constant speed. So the constant speed means the absolute value stays the same. So actually in this graph, speed is always changing. Same. Changing. So in between time is 5 and time is 8, it is moving at the speed of 4 meters per second. Okay, in the interval of 5 and 8. Now graph the body's speed for time is between 0 and 10. Remember, the speed is same as velocity when velocity is positive. So it should have something like this. But when the velocity is negative, you're going to take absolute value sign. So actually this part is going to be flipped to this part. Okay, so this part. So it's going to be like a mountain, mountain, and a trapezoid. Mountain, mountain, trapezoid. So D is the best choice. Finally, graphs acceleration. Graphs acceleration. Well, how do you find the graph of the acceleration? Remember what the velocity and the acceleration are related. So we have some kind of function, the velocity, and acceleration is given by the derivative of the velocity. Okay, acceleration is the derivative of the velocity, or the slope of the velocity graph. So now looking at the velocity function, so the velocity has a slope of 4 between 0 and 1. So between 0 and 1, velocity is actually 4. Okay, at 1, it suddenly move in negative direction, whereas the slope become negative 4. So between time is 1 through 3, slope is negative 4. So the acceleration is negative 4. Okay, and 3 through 5, again, it has a positive slope of 4, so it's gonna be like this. And at 5 through 8, there's no change in the speed, slope is 0, so 5 through 8, slope is 0. And after 8 through 10, the slope is negative 2, negative 2, negative 2. So it's going to be like this. Okay, so the answer looks like this. And the best choice is going to be C. Okay, so acceleration is actually rate of change for the velocity, which is same thing as the slope of the velocity function. Okay, so this is again the review question. Just find the equation of the tangent line at the point. So it's kind of easy to do, but I can show you is this. So basically same thing. I just need to find the slope of this function at the point -2 and f of -2. Oh, I should say 16. And I'm going to find the slope is -24. So I just find the equation of the tangent line where, so the equation of the tangent line is y minus y value is equal to slope times x minus x value, which is x plus 2. Like this, okay? Now you see it looks like a tangent line, correct? Okay, so just copy this. Minus 24x plus 2 plus 16. That's it. Continue. Okay, well, I'm just copying the answer from this one. Okay. Okay, one of the hard questions in this section, which is looking at this picture to answer to many questions here. So many questions. It looks like having like a 10 parts. Okay. So let's look at the question. When a model rocket is launched, the propellant burns for a few seconds, accelerating the rocket upward. So after burnout, the rocket coasts upward for a while and then begins to fall. A small explosive charge pops up out a parachute shortly after the rocket starts down. The parachute slows the rocket to keep it from breaking when it lands. The figure here shows the velocity data from the flight of the model rocket. Use the data to complete parts A through Z. So this picture is showing the velocity over versus time. You see the first part between like time of 0 through 4. The speed velocity is actually increasing, increasing, increasing. So it's getting faster, 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 faster. At this point, it has a maximum speed, maximum velocity. Then it starts to getting slower, slower, slower. But the position of the rocket is still moving up, okay? Rocket is still moving up because it has a positive slope, I mean, positive velocity. So rocket is still going up, going up, going up, but it's getting slower, 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 okay? At some point, the velocity becomes 0 around time is equal to 8, okay? So at time is equal to 8, the velocity becomes 0 and the velocity becomes negative afterward. The velocity is negative means rocket start to fall down. So it's getting fall down, getting faster, it's a free fall, getting faster, faster, faster. And at this point, something happens. So the velocity is actually getting smaller. I mean, the speed is getting smaller. Okay, so it's negative 20, negative 30, negative 40, negative 50. It's getting faster, but at this point, it's changed to negative like 10 or 20. So speed is getting smaller. Velocity is getting closer to 0. Okay, so that's what the parachute is probably doing. Now let's answer the question. How fast was the rocket climbing when the engine stopped? So engine stopped around this point, so I need to find the y value at this point because I was asked to find this velocity. How fast? Velocity when engine stopped. So engine stopped at t is about 4, so I need to find the maximum value here. So I can click here to show this, and you see this is maximum height, and the time is at 4, and you see the velocity, maximum velocity seems to be 125. Okay, B. For how many seconds did the engine burn? So the engine is burning to propel the rocket getting faster, faster for the first 4 seconds. So the answer is 4. Okay, when did the rocket reach its highest point? Well, I answered 8 first, but actually the answer is 7.9, which is very tricky. So it's actually the velocity becomes 0. That's the time the position reaches its maximum point, maximum height. And when this is 0, it's very hard to see, but actually the it's very close, but it's gonna be here. I don't know, here. That's approximately 8, but it's more closely, it's like maybe better. I mean, the answer is 7.9. It's very hard to see it, but it's 7.9, okay? Okay, what was the rocket velocity when it reaches its highest point? That's the time that velocity is 0, okay? Now, when did the parachute pop out? That's here, that's here. So again, have to be careful. So this is the moment that the parachute start working. So it's 10.4, 10.4, okay? And how fast was the rocket? Falling when the parachute pop out. So I need to find the velocity at this point, or speed at this point, which is negative. Velocity is like it's 1, 2, 3, 4. So it's gonna be like negative 80. So velocity is negative 80, but it's asking for how fast it's falling. So falling already indicating the direction, and it's only asking for the speed. So the answer is 80 feet per second. Now, how long did the rocket fall before the parachute opens? So it starts falling down. It starts falling down from 7.9 seconds, and the parachute pop out after 10.4 seconds. So the difference is the time it was falling down until the parachute pops out. So it's gonna be something doesn't work well. My keyboard doesn't react well. For some reason, I cannot type. So I guess I have to do something else. Anyway, so the time it start, the parachute opened at t is equal to 10.4, but the object started falling down at t is 7.9. So I do subtraction to find the time it took. Again,